Next up, we're working on an example. So what we're going to try to do is we're going to try to solve this differential equation. Y double prime plus 4y prime minus 2y equal to 2x squared minus 3x plus 6. And I'm just going to say up front that if we went ahead and solved, here, actually, let's write that out. If we went ahead and solved y double prime plus 4y prime minus 2y equal to 0, we would have solutions y equal to e to the minus 2 plus root 6 x, and y equal to e to the minus 2 minus root 6 x. And you would just find that using the methods that we learned in the last section. And I've just given those solutions because the thing we're really interested in this section is how to find solutions that match the right-hand side of the equation. So using that notation, when we introduced this method, our g of x is going to be 2x squared minus 3x plus 6. And when we're applying this like principle A, we just use terms that show up in g of x to build our g1, g2, so on and so forth. So here I see an x squared, I see an x, and I see something that's a constant, and I'm just going to call that a 1. And so my y sub p, I think, should be a times x squared plus b times x plus c times 1, where a, b, and c are unknown. So what I've done here is I've said, okay, my g1 is x squared, my g2 is x, and my g3 is 1. And then I need to find a, b, and c, where when I plug in yp to the differential equation, it turns out that yp is a solution. Now I'm going to put a little dot there because c1 looked kind of weird. Okay, so if I say that that's what yp is, then the derivative is going to be 2a times x plus b, and the c times 1 goes away. And then the second derivative is just going to be 2a. So those are derivatives with respect to x because x is our independent variable in this differential equation. And when I plug this into the ODE, what we're going to have happen is we want yp double prime plus 4yp prime minus 2yp. So that's going to be 2a plus 4 times 2ax plus b minus 2 times ax squared plus bx plus c. And what I'd like is for that to be equal to 2x squared minus 3x plus 6. That's the right-hand side of the differential equation. So I want these two things to be equal to each other. So in order for that to happen, what I'm going to need is, let's see, I've got 2a plus, I had 4 times 2ax plus b, so that's 8ax plus 4b. And then I had minus 2ax squared plus bx plus c. So minus 2ax squared minus 2bx minus 2c. So all I've done is multiply out everything right here. I want to have that equal to 2x squared minus 3x plus 6. So what does that mean for us? I said our general approach is to assume we know what y sub p is, plug it in. I've done that. Now we have to group like terms. And I said we're going to look for things that look like G1, G2, so on and so forth. So the things that look like G1, G2, so on and so forth are the x squared, the x, and the 1. So what I want to do is group on both sides of the equation things that look like x squared, x, and 1. So I've got my x squared terms on the left-hand side are made up of just this minus 2ax. I'll try to be consistent about using some colors here to help keep things organized. So minus 2a times x squared. My x terms are going to be, let's see, here's an x term, there's an x term. So I've got 8a minus 2b. And then my 1 terms, or just constant terms, however you want to think about that, are going to be 2a, 4b, and minus 2c. So I've got 2a plus 4b minus 2c. And then on the right-hand side, it's already grouped according to those terms. X squared times 2 plus x times minus 3 plus 1 times 6. And what we're going to do is set groups of coefficients equal to each other according to what they were grouped with. So for us, what that's going to be is I want to have minus 2a is equal to 2. 8a minus 2b is equal to minus 3. And 2a plus 4b minus 2c is equal to 6. Where all I did was I said, oops, wrong color. Okay, so my x squared term on the left side was minus 2a. It's 2 on the right. My x term was 8a minus 2b on the left, and that's minus 3 on the right. And my 1 term was 2a plus 4b minus 2c on the left, and it's 6 on the right. And I said I would explain why we do that. So when we set these groups of coefficients equal to each other, we're saying this equation needs to be true whatever the value of x is. And the only way it's going to be true whatever the value of x is if the things attached to all the x's are the same. So you can kind of imagine if you plugged in 1 for x or 2 for x, it would change the equation a little bit. But as long as the things attached to the x's stay consistent and equal, then this equation will always be true. And so at this point, what we've done is we've taken our differential equation, we've plugged in a solution, and we've said that in order for it to be a solution, this algebraic system of equations has to hold. And so we just have to solve these equations to solve our differential equation. So if we want minus 2a to be equal to 2, that means that a is equal to minus 1. So there's one thing that I've already found. If I want 8 times a, so 8 times minus 1, minus 2b to equal to minus 3, then I want minus 2b equal to minus 3 plus 8. So that's going to be 5. So that's going to be that b is equal to minus 5 over 2. That's another thing. If I want 2a, so 2 times minus 1, plus 4b, so 4 times minus 5 over 2, minus 2c equal to 6, then that's going to be, let's see, minus 2c is going to stay here, is equal to 6, plus 2 is 8, plus 10 is 18. And so that's going to give me c is equal to minus 9. That's a third thing. So now I had originally said y sub b was equal to ax squared plus bx plus c. Now I know that what that actually is y is equal to minus x squared minus 5 over 2x minus 9 by just plugging in my a, b, and c. And so the general solution just puts this together with our our fundamental solutions that we started with. So we want y equal to c1, y1 plus c2, y2 plus y sub p. So that's going to be minus 2 plus or minus root 6. Y equal to c1 e to the minus 2 plus root 6 x plus c2. Actually, I'm not going to have enough room there. Y equal to c1 e to the minus 2 plus root 6x plus c2 e to the minus 2 minus root 6x. So that's our general solution to the homogeneous equation. And then I just add what I found for y sub p. So that's going to be plus negative x squared minus 5 over 2x minus 9. And at that point, the problem is solved. So I ran a little over with all the algebra. Sorry about that. In the next video, we'll talk about some additional considerations we have for different types of G.